Yep. Can you hear me?
Anthony.
Hey.
Awesome. Awesome. Okay.
Sweet. All right.
So let me pin you real quick and see if you can. Oh, shit. Let me see here.
You just have to make me the presenter. We're not actually presenting live, right? To the.
Well, it is right now.
Okay.
It's all good. It's all good. Nothing's happening right now anyway. So
Just
let's see.
introduce me in the beginning so that so that you don't have to make or just like when you do the team, like, oh, the team is here. Just like say, oh, and Anthony is like on the line or something. So that.
Yeah. Okay. Yep, I'll do that. So do you need to, should I try just giving, so let's see here.
Make me presenter.
Present to everyone, okay? I'll make you presenter.
Yep, so now I'm presenting, and then I need to screen share. Which
okay.
I will screen share this.
Yep, screen share for a second, and then let's see. Cool, awesome. So I think it's working. Let's see here.
And then can you take it back now?
Yeah, let me try right now. So
let's make sure that's seamless.
Okay.
Yeah.
Let's wait and see.
I see your screen now and you're presenting.
Oh, cool. Okay. All right. Whoa, it's going back and forth. Okay. No, I think it's good. So how do I pin? Like, I think I pinned it. Okay. I think we're good.
And yeah, so.
You're talking right now and it's not flipping back and forth, so I think we're good.
Awesome. That sounds good to me.
Okay. You're all set?
Yeah, man.
Sweet. Okay. I'm just going to go on mute because all this is going to be recorded, so we're going to have to cut this out anyway. Okay. I'll talk to you on Hangouts. Bye. Good morning, good afternoon, good evening, everyone. If you can hear me, please type in the live chat. I want to make sure we have good audio here. All right, well, hey, today is election day here in the US, and I'm not seeing many people voting on our survey. I'd love for you to get out and vote. All right, thank you for voting. I think we all have the obligation to go out there and vote, given that we're all people here and have that opportunity. So whether it's voting for your president or voting for your experience with the Google Cloud, it's important to let us know your experience. Great. I think we're going to get started. Anthony, are you there?
Yeah. Hey, what's up, Jonathan?
Anthony, thank you so much for joining with us today. Well,
No problem.
I think there's about 16 people watching right now, and I just want to thank everyone for coming out here to this online meetup. It's our very first online meetup, and it means a lot to us. So thank you again for coming out. This is going to be very informal, interactive. We're going to try to make it as fun as possible, and the real value here is to interact with us in the chat room. So I've brought my best and most talented engineers here in the room with me, and they're here to answer your questions. So remember, I think the real value is interacting with us, because you can obviously view webinars all day, anytime. So please go ahead and interact, and let's have a good time. So the expectation today is just high level, one-on-one. We're not going to do a deep dive. We're going to use the subsequent sessions to do deep dives into our technologies. Actually, we have Collins, who's sitting right next to me. He's doing an App Engine deep dive next month, and I'm personally really looking forward to that. So high level, if you're getting resolution issues, if you can't read the text, go ahead and go to the bottom right-hand corner and adjust the resolution. Sometimes we had some users having problems with the way that they're looking at the video. And email us at gcpmeetup@google.com if you want to get started. If you have any questions, we're happy to answer questions. Just don't ask us to write your app for you. We probably won't do that. So here's the team. I'm excited to have some of the best and smartest people with me today. We have a team of solution architects and engineers helping customers to be successful. I'm Jonathan. We have Colin, Ria, Anthony, Vivian here with me today, Shri, and we all have our specific expertise in specific technology. So please, again, interact with us. So public cloud, and public cloud can be scary, especially coming from on-premise. We have a lot of customers coming from on-premise, and the idea of going to public cloud is just so many unknowns, right? There's a lot of just concepts and technologies that they're not used to, and the goal of Google Cloud Platform is to make that as easy as possible, the transition from on-premise to off-premise. So how is Google Cloud Platform different? I'm sure you've been inundated with a lot of information from different cloud vendors telling you about how you can help reduce costs, be more agile, help with elasticity. But if you can only remember one thing today, is with Google Cloud Platform, you can run your business on the exact same infrastructure and technology stack as Google. So I'll repeat that one more time. You can run your business on the exact same infrastructure and technology stack as Google. So as you digest that sentence, you're probably thinking, well, I only have a couple thousand viewers on my website. I only have, much less people than 1 billion users. Why do I care about running on Google infrastructure? Well, efficiency. As we grew the number of services to 1 billion users, do you think we had to linearly grow our operations to address the increase in number of users? Absolutely not. And to do that, we had to automate everything. And these are the type of technologies we're externalizing and productizing to our customers through Google Cloud Platform. So for example, many of you probably heard Kubernetes, Dataflow, BigQuery, just a few technologies that we've had to build in order to compensate for the growth in the number of services and users that we have on our platform.
Yeah, and I think one thing I'd add to that is that, and I'm sure I think there's a couple slides covering it later, but really with efficiency comes less of a focus on things that just keep the lights on and allows, really businesses to really focus on what makes their company or their organization unique. And perfect timing.
Yeah. Yep, exactly. So I think to understand where we are today, let's talk about our vision, right? The first step in the IT kind of life cycle is we first did colos. And colocation was kind of a marginal improvement. You're still managing physical hardware. You're still creating and building out your OSs. You still have bill of materials where you're building out your server. And it's still very complex. The benefit is you don't have to deal with cooling. You don't have to deal with real estate. You don't have to deal with heating. And that's great. It is a marginal improvement. But as we move on to the second wave, virtualization is what really drives a lot of the agility, right? We abstract hardware, treat computer like files, and now that we treat them like files, you can copy, paste, delete them, and you have a much more agile infrastructure. So many companies are still in this wave because it was only 10, 15 years ago where people were still using physical machines. So with virtualization, we're now able to do a lot of, build a lot of applications in a much shorter time frame. And so because a lot of organizations are still in this kind of wave 2, we're trying to do everything we can to improve this second wave. And we talk about security. We have large network. We run our own fibers, open standards, and we'll go into these in a little bit. We'll go into depth. Security is one of those topics that everyone brings up when we talk about public cloud. It's natural for us to think about what a supplier or a vendor is, how are they protecting our data, right? And being Google, it's very clear that outside of maybe military and government, we're probably one of the most targeted companies in the world by a very, very large margin. And because of that, we have around 600 plus PhD level type of security experts. We enforce encryption in at rest and in flight, and we have bug bounties, internal and external. We had a bug bounty for our, I think, Chrome OS. It was like $2.7 million worth of prizes, and that really shows how much we are investing in ensuring that security is of the utmost importance here at Google. And all our hardware is custom built. I mean, I don't even know what hardware we're using. We're building everything internally, and so all the hardware is the footprint. Because we can build our own hardware, the security footprint is much, or the footprint is much smaller and less attack surface for vulnerabilities and hackers to target. We talked about the network, and this is really what makes us very different as well from a networking standpoint. Is we run our own fibers across data centers, and no other cloud really does this. And we had to do this, right, to support 1 billion users. So we had to run our own fiber across geographies, and we're also building and expanding data centers almost one region every month, starting 2017. So you're going to see a lot of investments in our data centers as we continue to grow. Now, open source, many of you know Google's in the business of building great applications. And in the process of building great applications, we have to develop great technologies. So we're not in the business of selling the actual technology, which is why we do a lot of open source and pretty much put out a lot of white papers on this. And the benefit to the consumer is now that you have open source technologies like Kubernetes, it actually truly does provide you a cloud agnostic type of technology where you could run it on Google Cloud, which we believe is the best place to run it, but you could run it on any other cloud because it is open source. And we do that, again, because we want to foster innovation. We want other people to contribute, make Kubernetes better. And at the same time, we believe that the customers have a choice, and making it open source gives them that flexibility. MapReduce, it's just the last couple of years, got a lot of hype. We've been doing that for 10 years. Containers, we've been doing for 10 years until it became mainstream. We will launch billions of containers per week. So if you want to partner with innovation, that's really what we're doing here at Google. Now, pricing's obviously at the top of everyone's mind, and per minute billing is really important for our customers. And per minute billing allows you to pay what's fair for what you're using. We have a lot of customers that are building out their workloads, and they are trying to fill up that 1 hour by inserting weird scripts and weird workloads just so that they can maximize the use of what they're paying for. And for me, it kind of doesn't make sense. It kind of adds complexity, but I think per minute billing is really kind of the fair way to be pricing what you're really using.
Right, and I think kind of the past few slides really point towards our focus on the user, right? In terms of creating an experience that's focused on what they want and what they need. Again, open source technologies, we're not looking to lock anyone in. We're not looking to have anyone pay a cent more than what they use. Truly, I mean, that's really, I think, something that you'll find differentiates us in the industry, in the sense that a lot of the principles that drive what we develop in our businesses is again focused on what the user wants.
Right. Yep. And if you see here, this is my personal console. So when I log into Google Cloud, Google Cloud noticed that, hey, you're running this workload and it's not being utilized, right? And so it'll suggest that, hey, you can save $154 a month by reducing the machine type. And that's really important, because you might think, well, why would Google want me to spend less with us? And the reason is because we want you to partner with us, right? We're building a strategic relationship with our customers, and we want you to not pay too much, but we want you to pay what's right. And that goes back to, per minute billing, recommendations on reducing your workload size if you're not using it. And I think this is, when customers saw this, all they had to do was click the button and it said, would you like to, restart your machine? Yes, boom. Suddenly you're saving $154 a month. And we keep talking about investments, and $9.9 billion in 2015. Last 12 months was $11 billion, or almost $12 billion. That is more than the GDP of some countries. What are we doing with all that money that we're spending? So we talked about security. We make our own hardware. So we have the experience and expertise to build out the best, highly performant, scalable, reliable hardware in the world. We automate everything, which is how we can extend automation and reduce prices for our customers. So the fact that we automate everything means that we can help extend those cost savings over to our customers. And we have the largest network. We talked about the network. We lay our own fiber, and we have pretty much the fastest network in the world. So wave 3 is kind of the ultimate goal, right? No one wants to manage hardware, and infrastructure is really not that important to you, right? Infrastructure is very important to us, but to you, you just want your application to work. And since nobody can provide at our scale, we're required to build our own network, hardware, and storage for optimal automation, security, and performance. And Kubernetes, data platforms such as BigQuery, TensorFlow, these are all things that we see in the third wave as improving and accelerating the delivery of applications.
Right, and with those two, sorry, before you jump into the
what
it really is, these are non-trivial things to implement outside of a managed service, right? So setting up a Kubernetes cluster, being able to declare that through a simple API, being able to allocate nodes and the computing resources for those nodes through simple declaration from, it's really transformative in terms of what it allows you all to focus on, or what allows our users, the customers I work with, to focus on. So it's really powerful, and we're excited about it. Right, Jonathan?
Yeah, no, I'm super. I wake up every morning jumping out of bed. So it's really cool, because I mean, this is not just a Google thing, right? I think everyone is trying to achieve this level of application design where they don't have to set up the OS, they don't have to patch, they don't have to secure it. They just want to run their app. I mean, that's what I would want, right? I just want to run my app. I don't care about what OS I'm running, to be honest.
Yeah, and last thing if you'll indulge me, the last thing I'd comment on is really, like, take Dataproc, for example. It's a managed Hadoop service, and being able to, typically if you're setting up a Hadoop cluster, you're paying for it, even if you're only using it in certain instances, paying for it like it's persistent, right? Because you're setting up that cluster. But, with the power of not only Dataproc, but a lot of other things, you're able to really spin it up for what you need and then spin it back down once you're done with it. And it's transformative.
Yeah, exactly. So we have another poll up right now, and I'd like to understand, or we'd all like to understand where your current workloads are running. So if you can take some time to let us know where your workloads are running. I mean, I've worked with customers across the board here that have been running on all of these, right? On-premise, Azure, IBM, Rackspace, and there's some other smaller niche cloud players that I've worked with as well. But in general, at Google, we're working with a variety of different customers, helping them, either reduce cost or helping them to use technology that we've developed internally, hosted on our platform. I'll give it a couple more seconds. Wow. So on-premise, Google Cloud, Amazon. Okay, great. All right, so we'll keep going here. So I'll be honest, the first 15 minutes was very marketing-ish, right? And I want to get into, well, what do we actually have on the Google Cloud Platform? The short answer is pretty much everything, right? Storage, machine learning, big data, compute. We have it all. And again, it's because we have to support applications that support billions of users. We're required to have a lot of these technologies. And so most companies are still leveraging physical or virtual machines due to the nature of how applications have historically been built. So we offer VMs for net new applications. And as applications continue to scale and get broken down, containers become really appealing, right? Where you can now abstract the OS level. And finally, a full PaaS model, such as App Engine, which requires zero infrastructure deployment and provides for auto scaling and auto load balancing, is kind of the ideal place where you want to run your apps. And so with GCP, we see this continuum from IaaS all the way up to PaaS. And the reality of the industry is that we're just in a place where so many customers are in so many different environments that having all these options makes it as flexible as possible for our customers to build great applications on. The compute engine, right? This is kind of the basic virtual machine that we all have grown to love. And so we provide a breadth of operating systems that basically support any workload. We have SQL Server on Windows. We have several distributions of Linux. When we say fast and easy provisioning, we're talking about sub-minute range. And I know Anthony's going to do a little demo in a little bit. Sorry to already tell the punchline, Anthony, but
no worries.
Yeah. So, I mean, it's fast, right? And it's important that we mention how fast it is, because everything you build on top of these VMs is going to depend on how fast these VMs boot up. So if, let's say, you need to scale out, if it's going to take you minutes to spin up a virtual machine, that means that you have a degraded customer user or user experience for your application. So the fact that it's very fast means that your users of your application will not see any kind of degradation as your app continues to grow. One of the key differentiators that surprisingly not many people know about is the live migration, right? When we do maintenance, we are not going to ask you, hey, please shut down your VM. We're just going to live migrate it over to another server and put it back without you even noticing. So when we actually applied patches to Heartbleed, you didn't have to do anything. You just kind of sat there while we patched the infrastructure. You talked about billing, the per minute billing, and obviously, compliance and security. We talked about how much effort we go to make sure that our infrastructure is secure and reliable. Any comments, Anthony?
Yeah, I mean, I'd say that if, it's understood that compliance is a very important thing, especially in terms of if you're moving off of on-premise where you have very granular control of your environment. So what I encourage everyone to do is there's a lot of white papers that we've actually published that review, security best practices, how we handle encryption on our end, again, requiring no configuration on the end user, our customers. So really, I would encourage you to look not only at what, again, the compliance that our products are, the standards that we're held to, but also what we're doing in terms of, kind of making the transition to the cloud worry-free, right? I mean, that's really what we want the experience to be. We want you to understand that, we can make this an excellent place to run your workloads without a lot of the worries that come with the perception of cloud. So
Right. So I'll let you take it from here, Anthony, and I'll give you presenter mode.
Yeah, sure. Let's see. Oh, man. All right, so looks like it's on me now, but there is a little comic. Some of you may have seen it for like 2 seconds, but pretty much it's oh, no worries. I'd like to describe it. I think I might be a little better at telling the joke, but or it'll crash and burn. So one of the two. But pretty much Dilbert's coworkers are saying, it's going to take me a few months to spin up these servers to handle our web traffic. Boss says, hey, Dilbert said that it would actually only take a few minutes with the public cloud. And so Dilbert is thrown under the bus because his coworker is now mad that he has to do work. But hopefully we're going to prove that comic wrong and in multiple ways. One is that, hopefully it's not a lot of work, so his coworker has no reason to be mad. And man, I'm actually, now that I'm listening to myself telling it, the joke's not that great.
Yeah, that was a disaster. It's okay though.
Yeah. It's being a great storyteller has never been my thing, but the bottom line is we're gonna also blow by that few minute metric that's mentioned in the comic. So really, what I'm showing you right now, and I believe everyone can see my screen. I'm seeing it at least. So I'm diving in here to my Cloud Shell, which is basically an ephemeral instance, kind of a control center for the rest of my project within my Google Cloud Platform project. So what I have here, and I've I have a script here called create-vms, and what this is doing is it's using a gcloud command to create 100 instances, 100 one-core instances in our US Central 1 data center. So I'm going to execute that script, and we're going to watch it fly. Now, kind of what the reason that we're going through this demo is, again, if you look around, this is not for us to say, hey, there's some published SLO on our boot time. This is nothing like that. This is more so I want to show you how comfortable we are in terms of really how consistent the services is. And let's take this out of the context of me not just creating 100 VMs off of a base image, but let's evaluate it at a level of, let's say that you've set up an autoscaler and suddenly you go viral, or your traffic 10x's, or whatever reason, your marketing campaign finally paid off, or you have a guy in the street swinging a sign around and everyone's going to your website, right? You need to be able to count on a vendor to be able to, again, meet those traffic needs in terms of resources in a very fast and efficient manner, right? And so that's kind of where, again, not to go too much into the marketing aspect of it, but the way I see it is that we're a partner. We're here to help your business. We're not just selling you something. We're here to work with you so that you're successful. And so as you can see, that script created 100 VMs, and those are all created now, and I can see them all. And so what we're going to look at is actually the activity in terms of the diff between the time that the first VM was created and the time that the 100th VM was created. So let me see if I can get my dashboard to reload. But again, what you'll see there is that really it spun up in that sub-minute range, right? And I think if you are going to other cloud vendors, you'll see that that's not something that really they're able to provide. And again, this goes back to the efficiency that we're able to provide it in terms of the service. So again, there's no such thing as fishing for the good instances. There's no such thing as, well, can I count on this boot up time? And then one day it'll be 3x that. Really, again, you're going to find this consistently within the sub-minute range. And again, so many use cases where this is important and key for our users' businesses. So,
yeah, no, thanks, Anthony. Yeah, I mean, and I always tell customers, don't trust what Anthony just did, right? Do it yourself.
Yeah.
So
yeah, don't trust me.
Yeah.
If you walk away with one thing away from today, so.
Because I mean, we've all seen demos, and all demos are very flashy, but ultimately, you have the ability to test it yourself, and I think that's important to know. So yeah, I appreciate that. Thanks for doing the demo for us, Anthony.
Yeah,
so let's go into Container Engine. And I don't know if anyone's done containers without orchestration, but it's very painful, right? Figuring out where your containers are, making sure that they're up, exposing the right ports, the list goes on, right? And that's why there's a lot of companies out there who are investing in technologies to manage all this complexity around containers, because containers themselves are great, but how do you orchestrate all of these containers? And so with Container Engine, these are really good for customers looking to break down the application into small microservices. And while you can run, Kubernetes and Docker anywhere, we have Container Engine because we realized that the complexity in standing up a Kubernetes cluster was just, surpassed the amount of effort just to build an app on Kubernetes. So for a hosted environment, it allows you just to have an API endpoint and allows you to just write your app so that point it to API endpoint and boom, you're already using Kubernetes and getting the benefits of rolling updates, getting the benefits of ensuring that your containers are up, exposing endpoints to the public so that you can have certain services not exposed to the public, whereas some are only internal within a Kubernetes cluster. And so all these things that Kubernetes does just makes your life easier as a business, right? Your job is to keep your application up and running well, while not managing security updates, patches, and things like that. So, Kubernetes, as many of you know, came from our experience and expertise with deploying billions of containers every week for the last 10 years. It's really that simple. So App Engine, we have two types of App Engine: App Engine Standard and App Engine Flex. And at a high level, App Engine is really good for developers who don't want to touch infrastructure at all, right? And for App Engine, to be completely honest, you pay a premium for App Engine because you don't have to deal with any infrastructure. It auto scales, it takes care of your storage, and it load balances and it does health checks for you, right? So you get a lot of benefits in leveraging App Engine for your app. Now, if you're doing a migration from, let's say, your traditional app to App Engine, it's probably not the best use case. But if you're building a new app, many customers look at App Engine to reduce the complexity of operations. So we talked about the difference between standard. Well, we talked about standard, but Flex actually provides a little more control, and it's actually a little bit cheaper. But with Flex, you can actually choose the runtime, and you can deploy Docker containers into our App Engine environment. So the real difference is if you want a lot more flexibility than what App Engine requires, then App Engine Flex, hence the name Flex. Any comments on that, Anthony?
Yeah, I mean, again, with Flexible, a lot of it really allows for a lot of users that customers that I work with will use it to install custom libraries that or custom runtimes that their application requires, right? And that's not necessarily the case with standard environments. So again, it does give you a little more of that flexibility, in terms of what you're able to build on it.
Right. So we'll go into storage now, and storage and databases. We have all types of storage and databases for your business. We simplify storing data as well. So for cloud storage, we have different types depending on your availability needs. You can store object data, and files are a common format for storing data, especially bulk data. So with Google Cloud, you can upload your file data to cloud storage, and then you can make that data available to a variety of other services. So, if you use any of our other Google Cloud Platform services, usually the first place to start is getting that data onto the platform. And that's usually where cloud storage, that's how you would use cloud storage. Some databases, and we'll kind of go into those in a little bit of detail. So this is one of my favorite little animations. I mean, when you think everything's going right, something usually goes wrong. And storing data in the cloud is great, right? You get the flexibility of accessing it anywhere, anytime, through any mechanism. But through times of natural disasters or just events that are uncontrollable, you want to have a backup plan. And that's where having multi-region storage is extremely important. So let's see. Whoa. Anthony, for some reason, I see your screen. Yeah. It's good now?
Oh yeah, sorry. I think it's still on yours.
Okay, it's on mine now.
Yeah.
Okay. All right. Good. So cloud storage, simple to access, multi-regional, regional storage. This means that when you store data in our storage, you don't need to figure out where to put that data because we automatically put it in, multi-regional buckets. A new feature that we recently came out with is this automated lifecycle management of your data, meaning that your data will automatically be moved to a lower pricing tier based on how often you access it. Now, this is part of our continued, partnership with our customers, making sure that they are getting the cost benefits from our automation, and they are continuing to realize, reduce costs by leveraging our platform. So Cloud SQL, SQL has been around for ages and ages, and with Google, we have our managed Cloud SQL. So it's a fully managed cloud-native deployment of MySQL. It's got built-in support for replication, backup, and just supports the standard APIs for connectivity. So, bottom line is simplifying the way you use SQL. SQL supports up to 10 terabytes of workloads, and it's accessible from all the different services that you would be using within Google Cloud, such as Container Engine, Compute Engine, and App Engine. SQL, it's easy, right? Easy to use. There's no lock-in, flexible charging, and it's fully managed, meaning you literally click a button to create the SQL instance, and it's basically a SQL database ready to use that's patched, secured, and updated without you needing to touch a single operating system.
Right, and what I'd add on to that is again really things within MySQL that are again non-trivial to implement, like being able to set up read replicas, failover replicas, scheduling backups. These are things that again are all done through if you would like. There's obviously ways to access it to the API, but it's really all done with a few clicks through the console when creating the instance, right? And so within that, you're able to, again, have this sort of failover, again, handled by Google, which is, a pretty big deal in terms of in the case of emergency, having us supporting you in terms of being able to ensure that this MySQL workload is up and running is, again, another compelling story that, I've had experience firsthand with a couple of customers, right?
Yeah, exactly. And yeah, so, this is part of that third wave as we progress towards this third wave of how do we do as much as we can with what we have and make sure that everything we do is actually adding value to the business. So Cloud SQL, let's just get you the database you need. Don't worry about anything else. So data store. Data store is our simple NoSQL database. It does sharding replication on the back end, fully managed. And this is really great for high read. So the read performance of Cloud Data Store is actually dependent on the result set. So if you have, let's say, a huge data set, it doesn't matter how big your data set is. The performance of Cloud Data Store is actually dependent on how big the return or the result set is. So that means it's great for like product catalogs, user profiles, things that don't really change often, but is read constantly. So, fully managed, good for ACID transactions. It's got a SQL-like interface. So for those of you familiar with SQL, it makes querying a little bit easier. And with Cloud Data Store, you get that schemaless benefit of not having to build out your schema from the very beginning. And so it's very flexible.
Yeah, and what I'd argue with Data Store too is that it's perhaps even more quote unquote third wave than Cloud SQL, in the sense that you're not even dealing with instances and this is again something you're accessing through an API, right? You're not having to worry about, am I setting up read replicas? Am I setting up failover replicas? Not to say that, again, if you need a relational database workload, Cloud SQL provides a lot of capabilities around that. But Data Store, again, from an ease of access viewpoint, is pretty, again, another compelling story that we tell. So
yeah, no, that's a good point, because with Cloud SQL, you actually still create an instance, but it's managed, right? With Cloud Data Store, you don't even create anything. You just literally point your data, send it to a specific API, and that's it. Like, you don't even see the underlying infrastructure.
Right. Sharding, replication, auto-scaling, things like that are all handled by the service itself.
Exactly. So we talked about NoSQL. This is our other NoSQL database. So Cloud Bigtable, again, fully managed, high performance NoSQL database. It's really for large type of petabyte scale workloads, right? It's built on our internal Bigtable database infrastructure. And this powers search, analytics, maps, and Gmail. So this service really provides like a consistent, low latency, high throughput. So if you're, let's say, collecting a lot of IoT data, financial data, let's say you're building a monitoring app where you're just collecting just a tremendous amount of data, Bigtable is, one of the best options for you. So, Spotify, for example, they do about 360,000 data points per second for their monitoring system. We have a financial we're working with that collects over 25 billion stock market events per hour. This is a lot of data to ingest, and Bigtable is built around that requirement of gathering a lot of data very quickly. I'll say that the only kind of downside of Bigtable is that there's only one index, so you only have it's almost like you have to design it very well, and so we have a lot of best practices around designing your app for Bigtable workloads. So let's see. All right, this is my favorite topic: big data. Big data. I've worked with a lot of customers in the past who are trying to deploy big data, and it's really easy to understand. It's like, hey, big data is just like getting the ball in the hoop, right? You just want to have all this data. You want to uncover meaningful information about it. But when you actually start trying to figure out, how do you build the infrastructure for it? How do you how do you write your app for your big data environment? I mean, there's just so many layers of complexity that a lot of organizations really struggle with this. So I want to take a pause here, get some interaction going. I wanted to bring up this poll. I want to see how many people are actually paying attention.
No one pays attention to you.
Yeah, I know. This is just me and Anthony bantering back and forth.
A couple things too, while people are filling this out that is actually pretty cool is, again, I mean, I'm sure everyone was aware of the Pokemon Go craze that happened this summer. Can you believe it was this summer? That was a while ago, man.
I know.
But
It is crazy.
that was actually built on top of Data Store, right? And so
Yep.
again, thinking behind that is the ability to, again, be able to scale without having to manage, how you would be scaling to handle, that amount of traffic. And again, we have a great kind of blog, cloud platform, Google Cloud Platform blog that really details, the architecture of that and how our team was able to help them really scale to the biggest mobile experience of all time.
Right.
I guess phenomenon.
Yeah, I mean, the Pokemon Go is a very interesting use case because I think they had told us that we were expecting X amount of users, but they ended up getting like 10 or 100x the amount of users. So that was a kind of a firefight internally trying to scale up, physical resources. But thankfully we had enough, and we're able to scale out their applications for a successful launch in not only the U.S. but in the different regions that has become very popular. All right, so two votes. I'm a little disappointed by our voting here, but it's okay. I know everyone went out to vote for what really matters this morning. So unfortunately,
yeah, that's a little more important than
yeah, it's just a little marginally more important. But so, all right. So there's 3 votes, okay? One for compute engine, one for data store, and one for Kubernetes. I hate to break it to you, but the answer is actually Bigtable. I said that, Bigtable is kind of the database that runs, Google Search, Map, and Gmail. But that's okay. I talk fast, and I think I might have an accent as well. So no problems there. Let's continue on to big data. Big data, we can talk about all these products individually, but I think it best to show you kind of how they appear in the common big data pipeline. So this is the big data reference architecture, and we have a lot of customers kind of implementing this reference architecture in many different ways. But as a whole, you have all types of data, whether it's batch, whether it's streaming, real-time events. And there's 2 ways to do it, right? Well, for batch workloads, you're probably going to just dump all of that in cloud storage. And for real-time IoT devices, you need some kind of messaging system to manage all of that data and send it over to the right collection points.
Right, and it doesn't have to be IoT device data. It could be logs or any other type of, kind of time series data that's streaming in, right?
Yeah. Yep. And then Cloud Data Flow is our kind of no-ops ETL solution, which will take either batch or streaming and break it down and put it in a format that either Bigtable can process or something like a BigQuery, which will actually, I think Anthony will do a demo in a little bit. So basically, idea is you take data, you put it through some kind of messaging system, you transform it, load it either in BigQuery or whatever database you want, and you get to realize, and visualize results with our visualization tools like Data Lab. Plus, we have third-party plugins into our BigQuery technology platform. So I wanted to talk, I mentioned Spotify, but I think it makes sense to go over what they did, and I'm just going to do this at a very high level, right? At first they started with Kafka as their messaging system, and that's a typical choice, right? Because it's open source, it's free, and it's just very easy to get because it's open source. You just download it, start installing it. But for the scale of Spotify, Kafka was very unstable and very sensitive to the little changes that would require a lot of manual intervention. So restarting a node in Kafka producer cluster would cause weird issues and things like that. And this is all public information. Actually, if you just do a search for Spotify PubSub or Spotify Kafka, there's a huge, very comprehensive, in-depth analysis on why they chose to go to Google Cloud Platform. And they definitely did their homework, right? They know that Kafka is, quote unquote, free, open source, but they just realized that the operational expenses they were incurring on managing the infrastructure was just too much. So they went from Kafka went from running their own type of ETL, app, and just leveraged our pub sub, which is our messaging system, and leveraged data flow for extract, transform, and load. And they would load it onto either their HDFS, which is their Hadoop environment, and loaded it into Google Cloud Storage. So you can see that they radically simplified their environment and reduced just the amount of noise that was going on in their internal infrastructure. So I know we have 15 minutes left. BigQuery is one of these technologies that is just so amazing to look at. I mean, being able to process petabytes of information within seconds it just blows people's minds away. So I think, with BigQuery, it's technically two products, right? It stores data and you process it. And it's fully managed, no ops. You're not deploying anything. You just tell BigQuery where your data is, and then you run SQL queries on it. Very, very simple. And just some stats, right? 10.5 trillion rows, 38 terabytes. I'm pretty sure that these numbers are probably way beyond what you're using today or have in your environment. So Anthony, if you don't mind, I'm gonna hand over you for the demo. Anthony, are you on mute?
Oh, I was on mute.
Okay, I thought you left me in the dark there.
Oh, nah, man. You still have 13 minutes of my time, but then I'll leave it if we're over that.
So I just gave you presenter mode, but
yeah. Yeah, awesome. And I'll go through the demo real quick. I just wanted to close the loop real quick on those 100 VMs that I created earlier. And what you'll see here is that our initial one was created at 10:25, 14 seconds. 100th was created at 10:25 and 36 seconds. So this is something that we were able to get these instances up and running in a matter of 21 seconds. And so again, just, that'll be, I won't beat a dead horse, but again, really try and picture a real world use case where you need to be able to count on that scaling in that amount of time. But let's move on to BigQuery. What I'm gonna do real quick is, what we have here is a quick SQL query, and we're gonna be querying a public data set of Wikipedia page views, and we're going to be querying 100 million rows. So that equates to, I think, 5 gigs. Let's double check. Yeah, 5 gigs. So see how long that takes. And again, this is as simple as BigQuery gets, right? You get your data in. I guess before that, you would denormalize it, flatten it, and get it in as a CSV or new line delimited JSON. You get it into BigQuery, and you begin to query. There's no provisioning clusters. There's no provisioning IOPS in the way other managed data warehouses will have you do. Very much so, this is, again, how we see the third wave of cloud computing, is you being able to focus specifically on your business. And so what we're going to do now is actually stress test a little bit and turn it into run a 4 terabyte query over 100 billion rows. And I think one thing that is, again, really substantial to think about when kind of envisioning how BigQuery works is it really decouples being able to handle the processing for this query and loading in data, right? And I know that loading in data and migrating data into a data warehouse is often very resource intensive. It's a hog, right? And so when you're able to decouple that, then that opens up like capabilities for if you're streaming in data and you want a real-time source of truth for, let's say, logs or customer data or marketing data or click streams. BigQuery is such, it's really able to handle those workloads quite easily. And so you'll see that, we're able to process those 4 terabytes in about 37 seconds. And I think that would equate to I'm sure you all know 4 terabytes is a lot, but I think it's like a 500 Blu-ray movies, give or take. And so what's really special about this is that BigQuery scales out the more data you feed it, right? The bigger your queries are, the more we're able to scale out horizontally your execution engine. And so while typically if this would linearly scale, if we processed 5 terabytes in a few seconds, it'd be about 26 minutes, give or take, to run this query. But you'll see that it actually processed in 37 seconds. And again, It's really something that it's as simple as get your data into BigQuery and start beginning to think about what information you're looking for in your data. Don't worry about provision cluster. Don't worry about IOPS. Don't worry about the performance of your data warehouse. Just know that you can draw insights from it and draw insights from it in a very performant manner. And that's about it. That's what I had, Jonathan. I don't know if you're impressed or not. You've seen this a million times. So.
I hope other people are impressed because this is really impressive, right? A lot of our customers don't have large Hadoop environments and they don't want to manage it at all. So especially startups, they like to use this tool because it's really like a enterprise data warehouse at your fingertips, and you're only paying like literally like a couple dollars for each of these queries that uncover such valuable information. It's a tremendous tool for anybody to use. So let me take back presenter. And I think the last thing that we're going to do is go through machine learning. And machine learning is one of those topics that's really complex. I mean, you need PhD level people to really understand it, but it's so easy to get, right? Like machine learning. Yep. I'm taking, I'm looking at this image and I'm finding out what it is. It's a cat, it's a dog, but the brains and the mathematical algorithms behind how we do it is what makes this really, really powerful. And so Cloud Vision API, sorry, let me go back for a second. So these are all, what we call kind of fully trained models, right? Cloud Vision, Cloud Speech, Cloud Natural Language, Cloud Translate. These are all models that we've trained already. And all you need to do is upload your picture or upload your soundbite, put in some text, and we've already built the model so that it outputs what we think is the most accurate result. If you want to build your own models, right? We have customers who have things that are not on this list and they want to build their own model. That's where Cloud ML would kind of be useful. Going through these slides is always interesting because it's so easy to understand, right? I think we have, let's see, 8 minutes left. Anthony, do you want to do the demo or should we? Okay. Yeah, sure. I think it means much more if we show you the demo rather than going through these slides. And so I'll kick it back off to you if you don't mind.
Yeah.
Here you go. Perfect.
All right. Can you see my screen?
Yes, I can. I don't know. Can you guys?
I think everyone can.
Okay.
So yeah, again, this is something where today, this demo is really, it is a Cloud Vision API, but really I want you to envision this across all of our fully managed pre-trained machine learning models, right? So what we're doing here is we're submitting this image of a cat. And I didn't make this demo because if I did, it would be dogs. And I know that, there's very much a zero sum. You're either a cat person or a dog person. And so I very much hold true to that. But really what you're seeing is that we submit this image and we have multiple features available through the Vision API, right? So what you're doing is you're submitting this image and calling back and asking, hey, can I get label detection? Can I get image attributes such as dominant colors? Can I get the ability to check the probability of it being either not safe for work content, medical, with blood or violent content, and we're able to return all of this for you. And so previously, I mean, people who want to build applications around this functionality would have to train their own model. But what we allow you to do is submit this image, and you get a simple JSON response for all the features or kind of functionality that you requested in the API call. And what's powerful about that is again, this is the same kind of interface that you would be getting with Translate API, with NL, natural language processing API. These are all pre-trained models that you can just very seamlessly incorporate into your application. So for instance, if you're using Translate API, being able to submit a string of text and being able to get that language detection and get that translation into the language you request in a JSON document. And the same goes for natural language processing, being able to, again, to submit text and receive, this is the polarity or magnitude of, this text was positive in terms of sentiment, and it was so at this magnitude. And you're just getting these values that are, again, pretty powerful and again, non-trivial to implement if you're looking to set that up through other methods outside of these machine learning APIs. And again, the last thing I'd say about it is that your participation with it really does help strengthen the model. And these models are continuing to get more and more accurate, which again is all about the third wave, and that's what we're looking to do here, right?
Yeah, no, that's perfect. So thanks for the demo again. So let's talk about how to get started. I mean, a lot of these tools, like especially the machine learning ones, we have some just web apps that you can upload your image and play around with it. I mean, Anthony and I actually was working with a startup. They wanted to be able to identify kitchens and living rooms and bedrooms. And so they just, did their own tests to see how accurate it was. And I think they were pleasantly surprised. But, email us, gcpmeetup@google.com with your feedback. I mean, this is our very first one. So I'd love to hear how it went. If it went amazing, if it was terrible, we thrive on feedback. So let us know. If you want to do some code labs, this gives a kind of high-level experience, just very high-level overview of some of the technologies that we've covered today, and you get to walk through a couple coding exercises. Very, very high level, but I think they're useful to understand the concepts. And then, for those of you coming from other, other platforms and want to know if Google Cloud Platform has kind of, we have solutions for almost everything. So if you want to take a look at these architecture guides, I think that's a great place to go. And then we have some other webinars that are a little more formal, I'll say, and a little more scripted. So it's not going to, personally, I don't think it's as fun, but Cloud Webinars is a great place to hear from our product managers what they're going to be doing in the next couple months. And then I am going to try and send you this on the chat room. I don't know if I can do that right now, but I'm going to ask for feedback, and I promise that there will be a prize, and I will announce it to the meetup. So I will go ahead and do that. If you guys want to go ahead and type that into your browser, that's fine, while I go ahead and try to find the link. Okay, Data Studio Beta. Ooh. So Kala, I mean, we get announcements every day. I'm not actually up to date with the Data Studio Beta. Did that come out today? Yeah, okay. Yeah. See, sometimes our customers are actually ahead of us because we literally have an announcement every day. So let me go ahead and get this link out to you guys. All right, let's see here. That's it. We're going to stick around for another 2 minutes, and I hope that this was useful. And I want to thank everyone for joining. If you can give me 1 second while I try to give you guys the link so that you don't have to search it. Let's see here. All right, let's copy this. Oh, maybe I'll just paste it into the meetup. Let's see. Okay, well, thank you again. We'll be on the chat for another minute. And thanks, Anthony. And thanks, everyone here in the room with me for helping to answer questions.
Awesome. Thanks, Jonathan. And thanks, everyone, for attending.